Hey guys, this is Mr. C, and we're looking at Chapter 9, Lesson 4, which is on spheres. Spheres are three-dimensional. It kind of looks like a ball, and that's right, like a basketball, baseball, pretty much any sport, not football, but it's got that round, kind of looks like a circle that has air pumped into it. That's a sphere. Most of you already know that. So for spheres, we're going to be looking at two things: volume, which we've been doing for other shapes, and surface area. So really quick, I'll start with volume. Some of you already know this formula, and of course, all formulas are on your reference sheet. It's not something you have to memorize, but it is something I do want to just go over with you real quick. So 4/3 pi r cubed, that is the formula to find the volume of a sphere. So to apply this, remember volume, just so we know we're working with volume here. Volume is the inside of a three-dimensional shape. How much can go inside of it? So if I've got any kind of circular object, for instance, let's say a basketball, how much air could I pump into it? We'd be talking about the volume. So let's just take this sphere right here. What if I said that the radius was 12? Let's say 12 centimeters. And I asked what the volume is. It's pretty easy. You just kind of plug in your numbers and then just do your calculations. So that's what the formula would look like. You've got a calculator. It does not take much effort to do this. I'm pretty sure if you put this in a calculator that you'd end up with something like this. All right, and that's the volume of a sphere. I mean, we can look at one more problem just to make sure you got it. The diameter of a sphere in a water fountain is 4 feet. What is the volume? So we're dealing with a sphere, so we're going to take our sphere volume formula. Start with that. This one we're given the diameter, so if you know your stuff, radius is half of the diameter, so the radius, just to focus you, is really 2. Do not plug in that 4 just because you see a 4. Think about what you're doing. And then from there, it's pretty simple. Okay, you're plugging in 2 for the radius and then calculating. So if you do this out correctly, this is 33 approximately. I should change that. So it's about 33.5 cubic feet. Okay. And I guess I should make sure I answered the question, what is the volume of the sphere to the nearest foot? So that would actually be 34, because the nearest foot, that would be the nearest whole number. So about 34 feet of water can go into this spherical fountain. And that's really all there is to volume of spheres. As long as you know the formula, which you'll have, it's on your reference sheet, you just have to know how to use it. So the only real trick is if you're given the diameter, make sure that you are using the radius, not the diameter. And then of course there's going to be times where we do figures that have like a rectangular prism and then on top of it a sphere, and ask you for the volume. You would just combine those, but we'll work on those more in class together. This is just to get the basic gist of what we're doing. So that is volume of spheres. The other thing we're going to look at is called surface area. And really, if you break down what the words are, it's the area of the surface of the sphere. And what that means is if I have a sphere, if I could kind of like unroll it and lay it flat and just have like the skin, let's actually take a baseball. If I could take the leather off of the baseball, which is, it's a sphere, and lay it out flat, that would be the surface area, the area of the surface of the sphere. So the formula for this, it's not something that you have to memorize or that you would just know off the top of your head, but I'm going to give it to you. This is also on your reference sheet, but it's just something that you need to know the difference of. Volume is how much can go inside of something. Surface area is if I take that figure and kind of lay all the outside of it flat, what's the area of the surface? And I think a baseball is a good example, or any kind of, like a basketball. how much leather goes on the outside of the ball, the surface of the ball. And so the formula for surface area, I'm going to call it SA. Okay, surface area of a sphere is 4 pi r squared. Just want to make sure I have that correct. Okay, and I mean, there's nothing special in this. You know what r stands for. It stands for radius. And to find the surface area, you just pretty much plug in your radius and do it. You just have to know, I mean, word problems could trick you up a little bit. You have to know when you're supposed to use volume and when you're supposed to use surface area. Volume is when it says how much can fit in this. Surface area is what is the amount on the outside of it. So let's just, I mean, we could try this if you wanted to. Let's say, I don't know, let's give this baseball a radius of 9 millimeters. I don't think that's true, but we're making it up. So if the radius of this baseball is 9 millimeters, then 4 pi 9 squared would be my surface area formula, and then the surface area would be equal to 1,017 and 8/10 cubic millimeters cubed. And what that would mean is, if the radius of this is actually 9 millimeters, then the company that's making this baseball knows that they need this many cubic millimeters of leather, or whatever they're covering the baseball with, to manufacture one baseball, which does come in handy if you're in that sort of scenario or company or situation, because you're going to look for the most cost-effective way to make these things, and that's just one way you might use this. But we'll do one more surface area problem. Okay, let's say this sphere has a radius of 7. So what is the surface area formula? 4 pi r squared. And I mean, this can't get any easier. You're given the radius, so you just plug that in. Okay, do your calculations, and then you should come up with surface area is equal to approximately 616. And now I made a mistake on the last slide, and I'm going to go back. This is not millimeters cubed, this is millimeters squared. And the reason why is surface area, you're talking about, like, let's go with the baseball again. Taking that baseball and taking the skin off, the leather off of it, and laying it flat. It's not a three-dimensional thing that we're finding. Yes, spheres are three-dimensional, but the surface of it, if I could lay that leather out flat, it's really just a flat piece of leather. It's not three-dimensional. So since it's not a three-dimensional figure, we're not dealing with the volume. We're dealing with surface area that's going to make this squared, not cubed. And again, even just look at what you're multiplying. The radius is 9 millimeters. So really I'm doing 4 times pi times 9 millimeters times 9 millimeters. There's only 2 millimeters that are being multiplied, leaving me with millimeters squared. And in this one, I did 4 times pi times 7 feet times 7 feet, because it's 7 squared. And so it's feet squared in the answer, not cubed. That was a mistake on my part. Surface area, you're talking about the flat part of it. If I could take that sphere and unfold it and lay it out flat. Flat things are two-dimensional, thus your answer should have a 2. And when you're talking about volume, though, of course, that's three-dimensional. That's what can go inside of the three-dimensional figure. Then you're back to cubed in your answer. And that's pretty much all that there is to this lesson. So here are your summary questions. The first two deal with this sphere right here. Okay, it has a radius of 12 meters. And then number 3 and number 4 kind of play off of one another, so you kind of need the information in number 3 to answer number 4. But pause the video, write down the questions. I'm expecting you to try these. It should not take you too long, but please show your work, show the original formula, fill in your stuff and then calculate it out. And if you're having a little bit of trouble for this for whatever reason, or you just have a question about spheres or something else, you can always email me. I'll have my email on me this weekend, so just send one out. Other than that, have a good weekend, and I'll see you Monday, and then we'll be done with this chapter next week. So if you made it to the end of the video, here's a little sneak preview of Ella, who has the hiccups and is not very comfortable, but here she is, and I'll bring her into class one day, but I'm going to help her get rid of the hiccups, so have a good weekend.